In this video, I'm going to go through some of the highlights of VR in Unreal Engine, but first I want to give you a little background on VR in general to give you a better idea of why Unreal 5.1's new VR features are exciting for developers and gamers. Even though VR has been around since the mid-80s, it's only recently started to gain mass appeal and widespread adoption. If the technology has been around this long, why are we only now starting to see it become popular? While VR in the form we are familiar with today was invented in the mid-80s, VR gaming first showed up in the early 90s.
It was more than 100 years ago that Lewis Carroll wrote about Alice's trip through the looking glass. Now that fiction has become a reality, or you might say a virtual reality, because that's the name of a new computer technology that many believe will revolutionize the way we live. Jay Shadler explains, virtual reality lets you travel to places you've never been and see things you've never seen and do things you've never done without ever leaving the room.
Fly over Mars. Take a trek through a prehistoric jungle. Tour a house that has not yet been built. It's called virtual reality, and as Jay Shadler found out, all it takes is a special helmet and a glove, and you're off.
You're gone, John. You're history.
But it was too pricey and strange for most people to go out and buy it, so early attempts at the technology were financial failures.
It's a computer-generated world where you see and move and feel. Will real life ever be the same?
In case you're wondering about the virtual price tag for one of these systems, right now they run from about $50,000 to $200,000.
Beyond that, there were plenty of issues with the technology itself. Before we get into the issues with VR, let's briefly define it. Virtual reality is stereoscopic, meaning that it renders a separate view for each eye, which allows for the creation of depth perception and simulates how our own eyes see the world.
As with most VR systems, Waldron's uses stereoscopic images projected onto tiny screens inside the viewer's helmet. A powerful computer then generates the graphics and sounds needed to convince the viewer he's in another world. The illusion is completed when motion sensors in Waldron's glove and helmet allow him to begin interacting with whatever he sees.
What I can do is, as you can see, freely move the articles all around anywhere I like in space. Now, on a conventional computer, this would take an awful long time. Here in the virtual world, you just pick them up and move them around.
All of these elements make VR immersive and highly interactive, so essentially it attempts to recreate all the elements of the real world, but it's 100% virtual. At this point, VR has actually been in development for a long time, and has taken decades to get to the point where it's developed enough to be mass-produced and start to gain wide adoption. There have always been issues with latency and resolution, but VR is finally at the point where those issues are much less noticeable. It's not perfect, but it's good enough that most people won't notice it, and it's still actively being improved.
It's unreal. It's different. And it's so natural that when you experience it, it's something that people come out of the system and say, wow, that's unreal. Wow, that's unreal.
However, VR still has major limitations. One is that VR can be expensive to render. Other limitations include limited field of view, no zoom, and limited screen space effects. Much of this is due to player experience. These things can technically be done, but they cause an uncomfortable experience for the user and can make them VR sick, which is like a form of motion sickness. Users can also experience dizziness, eye strain, neck strain, and headaches. On top of all that, simply wearing the headset itself can be uncomfortable and unsanitary if shared.
By the way, headset hygiene, there was an ocular herpes outbreak at I'm not even going to say which event, but you got to be careful. You got to keep these things clean. You're sharing things between people. And that also is a totally legitimate reason for someone to say they don't want to put on a VR headset.
Because of many of the limitations surrounding movement and motion, it's common to use teleportation as a method of movement in VR. It's also best to have high frame rates with 120 FPS as a standard to reduce motion sickness due to latency. Let's get into probably the biggest change for Unreal in VR, which is OpenXR. XR stands for the combination of AR and VR, and OpenXR is a royalty-free, open standard that provides high-performance access to VR and AR. The biggest benefit is that this will allow designers to develop the VR version of their project once, and then deploy it to all the target platforms instead of having to essentially redesign your game for 8 different platforms. This is similar to how the Unity game engine works. Say what you want about the engine itself, but one of the major benefits is that it strives to streamline the process of releasing on multiple platforms as much as possible. The first thing you want to do when using OpenXR is tell whatever runtime you are using to use the same runtime for OpenXR. If you don't set this properly, you can experience weird behavior and bugs in your project. Here's a few examples of how this would be done using different software. Okay, now I want to talk about how to actually get started. The best way to start in VR is by opening up a template, and then go to Architecture and open up the Collab Viewer. And as you can see here, this is your out-of-the-box multiplayer template in Unreal Engine that makes it easy to have a host and clients and have it set up to collaborate with other users for a variety of different projects. This is what it looks like. Some of the basic settings you want to have enabled for your project are foveation settings, which are essentially LOD for VR. So if you're not already familiar, LOD stands for level of detail, and it's just a method of increasing your performance while still maintaining a good visual quality. So something that's been used for quite a while in the industry is LOD, which means that you have an asset with a high level of detail, and then you have different versions of that asset with less and less detail, so that when your player is farther away from an object, it uses the version with less detail so that it doesn't have to render as much. And since you're far away, you can't really tell that it's lacking detail as much, because that's naturally what happens when you're far away from something. You don't notice details. So it maintains the illusion of the same quality, but increases the performance. So that's essentially what foveation is, except for it's VR. So wherever your eyes are, there's higher resolution and detail. And with regular VR, it's usually just centered so that, where you're directly looking with your eyes, there's higher detail, and stuff on the peripheral of your vision is less detailed since you won't be looking directly at it. But dynamic foveation actually allows you to shift where change in detail is happening. So with more advanced VR sets that have eye tracking, the foveation will shift depending on where you're looking, so that whatever you're looking at has a higher level of detail, and the things outside of your direct field of view have lesser detail. Mobile HDR is graphical bells and whistles that essentially cuts your frame rate in half, and Round Robin gives you 1 extra frame of latency, but it has a significant render savings as a trade-off. And just as a side note, the industry standard currently for VR is Android, since most standalone devices run off of Android. Apple's also working on releasing their own headset, so we'll see how that changes things. One of the best features is that you can build from Android and Windows right out of the box. Forward rendering allows for much higher performance than with deferred rendering, but the trade-off is that you can't use Lumen and Nanite in conjunction with this feature. And this is also if you're primarily using baked lighting. If you are using real-time lighting, though, you'll most likely get better performance using deferred rendering. A lot of people don't like to be in VR themselves, but they do like to watch other people in VR, and the VR spectator mode allows users to watch the actions with a dampened camera, meaning they won't see all the movements the actual operator sees. It's kind of like if you're in a car, the person driving would be fine taking twists and turns because they can anticipate the movements and adjust accordingly. The same goes for the VR operator. It's a lot less nauseating for them than for the people watching them. So the spectator mode takes otherwise shaky gameplay and tones it down so it's more comfortable, enjoyable, and readable for spectators. Here you can see the VR template that Epic used at Unreal Engine to show these new features off. As you can tell, the camera is kind of janky, and depending on how the player is moving, it can get kind of nauseating for a spectator. You can see with the spectator camera in place, it's more stable, and you also have the ability to do a fly-through. These are the new VR hands that released in Preview 2, and this is a useful tool if you want VR hands as part of your project. Unreal Engine makes it easy to deploy to a number of devices, and they are also working on refining streaming with VR that functions the same way streaming does for traditional gaming. For example, it allows you to use a standalone headset wirelessly, but still get the graphical fidelity of something running off of a much more powerful rig. If you're just starting out in learning VR, or if you have already begun building a VR project but still don't know how all the pieces fit together, the VR templates can be an amazing resource. The idea behind a template like this is that it's already set up as an example of how an industry standard VR experience would be set up and how all the different elements would be integrated. This way you can dig in, break it down, and learn what a professionally created project should look like and apply this knowledge to your own project. Here are some of the features that are available out of the box. There are a lot of cool features, and this is the collab template. The ability to interact with others in real time is one of the best aspects of this project in my opinion. This is a good prototype for any project built around collaborating with other creators in a virtual face-to-face setting for work, planning, or just for fun. Of course, these templates aren't equal to a fully fleshed out project, but there was a focus on scalability when creating these templates, so they offer a strong foundation for you to build and add to for whatever you're trying to accomplish in your own real-world project. The next template is the virtual reality template, which you can access by going to Games and Virtual Reality. Even though this is in the Game section, I did want to mention that it isn't necessarily only viable for games. This template can be used for pretty much any type of VR project you're wanting to create. Now we're going to move on to what I think is one of the most exciting tips they shared at the conference, which is performance on desktop versus mobile, but it also applies to anything in between. In this example, there are 3 separate builds of the same environment with different target platforms, and I alluded to this earlier when I was talking about trying to do a single build and then hitting different target platforms with it and kind of streamlining that process. That's really the idea behind it, and you can see that there are different stages or different levels of graphical fidelity, essentially. So that's just a brief look at it, but I go into a lot more detail on this in my performance video. So if you click the link on that, then you can see this process in a lot more depth. Now for the final portion. This is what I think is the most exciting aspect of the entire conference, and probably the thing that everyone was waiting for, which is Nanite and Lumen in VR. So before 5.1, Nanite and Lumen were not available in VR, so obviously it's still in the experimental phase, so it's in a pretty volatile state and isn't very stable, but they're continuing to work on it to eventually make it production ready. That said, even in its current state, you can still see a lot of potential when you're running real-time reflections, real-time GI, dynamic lights, and overall highly detailed scenes. And it's really cool when it's working to be able to see the level of detail that's available with as much geometry as they have in the scene and how realistic it will look in VR. Some of the other limitations of the experimental version of Nanite and Lumen in VR are that it only runs on desktop and it's only available with deferred rendering and doesn't receive the performance benefit of Nanite yet. But these are all subject to change as they continue to improve the features and move toward production. So this is, as you're seeing right now, this is an example of it in action with assets from the Matrix demo. So overall, it looks pretty awesome and it's pretty exciting, and I'm excited to see how it develops. It'll be really exciting when it gets to a fully production-ready state. So hopefully they make good progress on it and that comes sooner rather than later. Anyway, I hope you guys enjoyed the video. Go ahead and like and subscribe to see more, and go ahead and check out my video on performance in Unreal.
Advances in computer graphics over the past 10 years are making it possible to create artificial three-dimensional worlds. Complete and convincing. Complete and convincing.
16 times the detail